Okay, hello everybody. I wanted to record this because I'm actually going to do a uniform variable. I'll just read this. Uniforms are another way to pass data from our application on the CPU to shaders on the GPU. But uniforms are slightly different compared to vertex attributes. First of all, uniforms are global, that is, within the shader program. Global meaning that a uniform variable is unique per shader program object and can be accessed from any shader at any stage in the shader program. So a shader program, again, is a set of shaders that all go through one pipeline that you define. Second, whatever you set the uniform value to, uniforms will keep their values until they're either reset or updated. Okay. To declare a uniform in GLSL, we simply add the uniform keyword to a shader with a type and a name. From that point on, we can use the newly declared uniform in the shader. Let's see if this time we can set the color of the triangle via a uniform, color of the triangles. Okay, so let's go into here and we're going to put it right here. Uniform. I feel like I'm typing unicorn. No. Vector 4. And we're going to call it this color instead of the in vector that I did from the there. So we declared a uniform vector for this color in the fragment shader and set the fragment's output color to the content of the uniform value. Since uniforms are global variables, we can define them in any shader we'd like. So no need to go through the vertex shader again to get something to the fragment shader. We're not using this uniform in the vertex shader, so there's no need to define it there. If you declare a uniform that isn't used anywhere in your GSL or GLSL code, the compiler will silently remove the variable from the compiled version, which is the cause for several frustrating errors. Keep this in mind. The uniform is currently empty. We haven't added any data to the uniform, so let's try that. We first need to find the index location of the uniform attribute in our shader. Once we have the index location of the uniform, we can update its values. Instead of passing a single color to the fragment shader, let's spice things up by gradually changing the color over time. Okay, so this will go in the loop, in the main loop, in the main render loop, to be specific. Render commands here, use program. Okay, so here. Oh, it's killing me right now. It's killing me at the moment. Yeah, something tells me it's way out there. We are already using the shader program, so we're going to just go with that. Okay, so there we go. First, we retrieve the running time in seconds via that. Then we vary the color and the range by using that in the green value. Then we query for the location of this color. Vertex color location equals GL get uniform location shader program this color, which you do not need to have the program in use at the time, is what they're telling you. If GL get uniform, it could not find location unless we set the uniform value using the GL uniform for function, which is right here. Green value, vertex color, location 0, 0, 0, green value 0, 1. It says note that finding the uniform location does not require you to use the shader program, but updating a uniform does require you to first use the program by calling GLUseProgram, because it sets the uniform on the currently active shader program. Because OpenGL is in its core a C library, it does not have native support for type overloading, and then it goes into the various things there. Now that we know how to set the values of the uniform, we can use them for rendering. If we want the color to gradually change, we want to this uniform irrigate loop iteration so it changes per frame. Otherwise, the triangle would maintain a solid single color if we only set it once. So we calculate the green value up to the uniform each render iteration. The code is relatively straightforward adaptation of the previous code. This time we update a uniform value each iteration before drawing the triangle. If you update the uniform correctly, you should see the color of your triangle gradually change from green to black and back to green. Where is it? Warning, initializing conversion from double to float, possible loss of data. Oh, so this is a float, so, okay. Oh wow, that is so cool. And of course I can still control the background, so. How do you make green? I don't know. Well, anyways, so that's cool. All right, well, thank you for watching. Be sure to like and subscribe and leave your comments in the section below.